All right, at this point in chapter 5, so you've got some paper you're taking some notes on right now. At this point in chapter 5, we've gone through the history of the periodic table. What we need to understand is how it's set up, right? Now we know how we got to this shape. We know why we've got 18 groups. Remember, these are called groups, the columns as we go up and down. And we have 7 periods. Remember, the periods are the rows going across. These two down here, they look like they're separate periods, but they're not. Remember, all of these elements actually fit inside of group 3. And since obviously there's no room to put them all in group 3, they're all so similar. They all have very similar properties. They all fit within group 3 here, but there's no room, so they've been pulled out so they line up across the bottom, but they're technically part of periods 6 and 7. So there is a general progression as we go across the periodic table, as we go from group 1, then to group 2, to group 3, all the way to group 18, that certain properties of the elements are going to change. And since they change regularly in a pattern, that's where the periodic part comes from in periodic table, right? Because there's a periodic change to there's a pattern to the change in the properties of those elements. So let's do just a little overview of what the different families within the periodic table are called and where they're located. All right, let's start with this big area here. The vast majority of the elements on the periodic table, right? Most of the elements on the periodic table are metals. We're going to specifically define what being a metal is here in a minute. But most of the elements that are found in the universe are metals. Okay? Then we have another group of elements here that are all similar to each other. And those are called the metalloids. So they're a little bit like metals, but sometimes they also act like nonmetals. And then the other big family of elements here are the nonmetals. Okay? They are specifically opposite of what the metals are. And again, we'll talk about what the difference is between those two. So the nonmetals outside of hydrogen, and hydrogen is a nonmetal even though he's way over here on the left side. He counts as part of the nonmetals. But for the most part, the nonmetals are over here on the right side of the periodic table. The metalloids sort of run along this. You see this bold stair-step looking line? Right? That is generally considered the dividing line. And so the elements that run right along that line are considered to be the metalloids. And then everything to the left of that stair-step line, except for hydrogen, are the metals. Now that is definitely something that you're going to need to know. So if you look at just any periodic table, it may not be colored like this. They may not show you where the metals and the nonmetals and the metalloids are. But you should in your head be able to picture where they are because you'll always know where this stair-step line is. Anything to the left is metals. Anything to the right is nonmetals. And then again, we have those few, and you don't have to memorize exactly which ones. You just know that generally right along that line, there are a few that can act either way, and those are called the metalloids. Now, specifically within each of those, within the metals, within the nonmetals, there are specific families within each of those that have their own specific properties. For instance, most of the metals that are here in group 1, outside of hydrogen, again, hydrogen's kind of unique, but all of the other metals that are in group 1 are a family called the alkali metals. And again, we're going to specifically talk what being alkali means. So those are called the alkali metals. Group 2 metals are called the alkaline earth metals. Okay. And then this big family here in the middle, These are called the transition metals. And they're called the transition metals because as you go further and further across those, they start to eventually transition over to being nonmetals when you get to the other side. Right? So these are all called transition metals. And then these, since they are technically tucked inside right here of the transition metals, we call those the inner transition metals. And again, they are all unique. They have some basic, unique things about them, but they're also all metals. And so when we talk about here in a few minutes, what's the difference between a metal and a nonmetal? All of these act like metals, but they also have their own unique properties. There's our metalloids. Metalloids don't have any, subfamilies or anything like that. And then when we get into the nonmetals, we have here in group 17, we have an area called the halogens. Okay, so the group 17 nonmetals are called the halogens, and the group 18 nonmetals are called the noble gases. And the word noble here really refers to the idea that these gases don't kind of interact with anything else. Right? They're gases that are perfectly happy by themselves. They're kind of like the noble lords that would live in the castle up on the hill, and all of the other peasants and everybody else would just live in the little town below. And the noble lords wouldn't have to actually interact with anybody else because they were rich and they had everything they needed, and they didn't need to go down into the town themselves. All right, so that's why we call them the noble gases. And so these different families that we talk about on here all have their own unique properties. And again, things just change periodically as we go across the periodic table. So it's important to have this picture in your head. For now, you're writing it down as notes, but at some point you need to be able to sort of picture where these things are when you're looking at a regular old periodic table that doesn't have all this information on it. All right, so here's the difference between metals and nonmetals. If something is a metal, it's going to be able to do certain things. Like, for instance, it has a distinguishing luster. When we say luster, we mean it has a shine to it. I'm sure that you've noticed that when you look at things that are made out of metal, that almost always you can tell because they have a certain shininess to them, right? Metals have a shininess to them. And that is unique to metals. It also is unique that metals don't come in a lot of colors. I mean, think of all the metals that you know of, right? Let's see, there's iron, it's gray. There's nickel, that's gray. There's zinc, that's gray. There's aluminum, that's gray. There's silver, that's gray. Right? Look at all these. Now, gold, obviously, is not gray. Yeah, gold is more of a yellowish color. Okay, and there's a few of them. Copper is more of a reddish color, brownish color. There's a few colors out there, but not a lot. Right? Most metals only come in just a very few number of colors, and most of them are gray. In terms of how they bend, right? We call their bendiness, we call that being malleable. They're very malleable. They can be bent into shapes without breaking. If you take a metal and you were to bend on it, right, it would bend. It wouldn't necessarily break, because that's what metals do. They bend, they're malleable. And they're also ductile. That means you can draw them out into wires. You can pull them and they would end up being these thin little wires. They're really good, metals are really good at conducting heat and electricity. The word conduct, that means that it can let it pass through. It doesn't create it. Metals don't create electricity and heat. They just are really good at allowing it to go through it. That's why we make our electrical wires out of metal. This is why we make our pans for cooking out of metal, because they're good at letting the heat, or in this, if you're talking about electrical wires, the electricity to run through them really easily. And the last thing you need to know, all metals are solids at room temperature, except for one of them, and that is mercury, which is actually a liquid at room temperature. Okay. So all the metals that we're talking about, All of those elements that were on that page from before, that were all to the left of that stair-step line, they all do these things, right? There are some differences in other properties between the different families within the metals, but all of the metals that we're going to talk about all do those things. The nonmetals are essentially the opposite. Metals had a shininess to them. Nonmetals basically don't. We call them non-lustrous. They're dull. Okay, they don't really have much of a shine to them. Whereas metals didn't come in a lot of colors, nonmetals come in a lot of colors. All right, if you look at a periodic table, and again, you should have a periodic table available to you right now. You should have either one on a piece of paper that you can pull out and look at while you're going over this, or you should have another tab open on your computer right now that has the periodic table that I posted in Google Classroom up, so that way you can look at it as I'm talking about it. So nonmetals come in lots of colors. So let's talk about some nonmetals like carbon. Carbon is black. Sulfur. Sulfur is yellow, bright yellow. Right? And then we have things like oxygen. Well, oxygen doesn't have any color, right? It's colorless. You're looking at it right now. Okay, you don't see it at all. Same thing with nitrogen. Nitrogen is colorless. And then we have things like chlorine. Chlorine's like a green gas. Bromine and iodine are sort of a purplish color. We have all sorts of different colors that nonmetals come in. Nonmetals are brittle. That means that if you try to bend them, they'll just break. They're not going to be malleable. They can be hard or soft, but they're always brittle. They're really bad at conducting heat and electricity. That means they don't allow heat and electricity to pass through them very well at all. And for the most part, metal or nonmetals are generally lower melting points than metals. Or in other words, a lot of nonmetals end up being either liquids or gases instead of solids. Now, that doesn't mean there aren't any solids. There are some. Right? Carbon is a solid at room temperature. Sulfur is a solid at room temperature. Phosphorus is a solid at room temperature. But there's a lot of them that are gases, right? Oxygen, nitrogen, chlorine, all the noble gases in group 18, those are all gases at room temperature. Okay? So you need to know the difference, right? What do metals do? What do nonmetals do? And then, of course, where would metalloids fall in this list? Metalloids would be right in between. Metalloids do a little bit of both. Okay, those are the elements that sort of fall in between, and they can't be classified as one or the other. So, once again, when you're looking at the entire periodic table, and you can kind of see this is this pinky area here, this whole thing, that's the periodic table, right? Outside of the 2 extra rows that they had at the bottom there. So if you want to think about this, here's where that stair-step line would be, right over here, right? That stair-step line would be right here. And we said that basically everything to the left there was a metal, and everything to the right was a non-metal, and there was a few metalloids along the edge there. But it isn't a perfect everything on the left exactly acts the same, and everything on the right exactly acts the same. Things become more metallic the further you go to the left and the further down you go. That means down here at this corner of the periodic table, this would be the most metallic any of the metals ever get. Out of all those things that metals do, this metal right here, which happens to be francium, by the way, this metal right here does metal things better than all the other metals. If you're talking about nonmetals, things become more non-metallic as you go to the right and as you go up. That means that over here in this corner, this element right here is the most non-metallic out of all the nonmetals. Out of all the non-metally things that things can do, it does it the best. And this would be helium. Right? And then, again, as things go further this way and further this way, when they meet right in here, that's the dividing line. And we say generally this is when things start to switch over between metals and nonmetals. Reactivity is another property we're going to talk a lot about. Okay? And reactivity just simply means how much does it go out and actually react with other things. So, for instance, for the nonmetals, reactivity increases as you go to the right and as you go up. But like I said before, the group 18 noble gases don't react with anything because they don't need to. We're going to talk a lot about noble gases here in the next couple of chapters. But they don't need to react with anything. So what's the most reactive of the nonmetals? That would be actually right here, the fluorine. Fluorine's very reactive, very, very reactive, violently reactive with other substances. And then for metals, reactivity increases as you go to left and down. So once again, and we get down to this corner, this is the most reactive of the metals. So francium would be a very, very violently reactive substance. It doesn't like to, just be by itself. It wants to react with other things and combine with them. So those are some of those properties that I want you to start understanding when you're looking at the periodic table. You're not going to have all of these different versions of the periodic table sitting in front of you during the test. You're just going to have one periodic table. But I want you to remember, when you're looking at it, how do the different properties change as you're going across, as you're going up, or as you're going down? And one of the keys is you understand that this side of the periodic table are the metals, this side of the periodic table are the nonmetals. Okay?